In this video, we're going to look at the problem where we are told to find the sum of the geometric series given by 1024 minus 512 plus 256 minus 128 plus all the way down to the final term, which is plus 1. Now, the difference with this problem, unlike a lot of the problems that you've been given, we've actually been given what the last term is of our series. It's 1. So that's going to be important. But let's start off by gathering the information that we normally would do. We'd normally list our first term, so our A value, which is nicely 1024, nice and easy. We can then list what our common ratio is, so our R value, which is our second term divided by the first term. That's the easiest way to find it. So minus 512 divided by 1024, which gets us minus a half. So we've got our two key bits of information, but let's look what this 1 actually means. Well, if it's our last term, in effect it is our nth term, because we don't know how many terms there are in the sequence, but we are going to need to find this. So our nth term is equal to 1, or in other words, un is equal to 1. That's what this means. So we can start to piece this together, and because we are given the value for the nth term, we can use the nth term formula and substitute in. So we can say that we have 1024 times our R value, which is minus a half, to the power of n minus 1, because we don't know what n is, but we do know that all of this is equal to 1. Rearranging it slightly, we've got minus a half to the power of n minus 1 is equal to 1 over 1024. Now, we don't really like this minus a half here. However, we really have in the numerator a 1 to the power of n minus 1. And regardless of what that power is, if it's 1 to the power of anything, it's still going to be 1. So actually, we can take the reciprocals of both of these and say that minus 2 to the power of n minus 1 is equal to 1024. That's a very key thing that you've got to spot in there, that 1 to, regardless of the power, is just equal to 1. So we're able to take the reciprocals. It's at this point that we actually have to break this minus 2 up and say, well, really, the minus 2 is made up of minus 1 times 2. So we have a minus 1 to the power of n minus 1 times a 2 to the power of n minus 1 is equal to 1024. All we've done is we've just split the number into minus 1 times 2, making sure the power still applies to both parts. Now, the fact that 1024 is positive tells us something about this minus 1 to the power of n minus 1. So as 1024 is positive, that implies our minus 1 to the power of n minus 1 must be equal to 1. Because if the power can only make this either minus 1 or 1, if it made it minus 1, this would have had to have been a negative value. Because it's positive, the minus 1 to the power of n minus 1 must be equal to 1. So in other words, we can say that 2 to the power of n minus 1 is equal to 1024. From this, in order to solve this, because we need to get a value for n, we're going to need to use logarithms. So we can say that we have 2 to the n minus 1 is equal to 1024. At this stage, probably nice and easy to introduce the natural logarithm to both sides. So you've got the natural logarithm of 2 to the n minus 1 is equal to 1024. Bring the power to the front as a multiplier, so n minus 1 times the natural logarithm of, that should be natural logarithm of 1024 there, 2 is equal to the natural logarithm of 1024. This is a multiplication here, so when it moves it becomes a division. So n minus 1 equals the natural logarithm of 1024 divided by the natural logarithm of 2. Finally, move the minus 1 over. N is equal to the natural logarithm of 1024 over the natural logarithm of 2 plus 1. Which you go to your calculator and it tells you that that's 11. It's a nice one, which is going to be very useful to us. So we've found how many terms are actually in our sequence, which is great because now we want to find the sum of our geometric series. So we've got a value for n, we've already got a value for a and r, so we just need to substitute those into our summation formula. So we have a is equal to 1024, r is equal to minus a half, n is equal to 11. So we have the sum of the first 11 terms is equal to our a value, which is 1024, times 1 minus our r value, which is minus a half, to the power of n, which is 11, all over 1 minus a half. 1 minus a half becomes 3 over 2, which means on the outside we end up with 2048 over 3. If you put the 1 minus a half to the 11 into your calculator, you end up with 2049 over 2048. The 2048's cancel, and 2049 divided by 3 gets us 683. And that is our final answer for the sum of this geometric series. So we're not given the number of terms for this one, we've had to find the number of terms, and then we've been able to use the summation formula. So it's a little bit more difficult, this one, but this is how you would solve it.